All right, so now let's use these identities to do something. Let's find sine of s using the Pythagorean identity given cosine of s is equal to 3/4, and our angle s is in quadrant 1. Okay, well, our Pythagorean identity says sine squared s plus cosine squared s is equal to 1. So let's plug in what we know. Sine squared s plus, remember that cosine squared of s is the same as cosine of s squared. So this becomes 3/4 squared equals 1. Cosine squared s plus 9/16 equals 1. Subtracting 9/16 from both sides, we get sine squared s equals 7/16. And as I mentioned with our notation, I'm going to go ahead and change this. This is going to be sine of s squared equals 7/16. Now we can apply our square root property and take the square root of both sides. On the left, the square and the square root cancel out, leaving us with just sine of s. But on the right, since we did square root property, we're going to get plus or minus the square root of 7/16. The square root of 7/16 simplifies down to the square root of 7/4. And now we need to determine whether we want the plus or the minus or both. The directions told us that our angle S was in quadrant 1. So is sine positive or negative in quadrant 1? Well, it's positive. Right, so we're going to throw out the negative and we get a final answer that sine of s is equal to the square root of 7/4. I gotta admit, if I was just asked to do this problem without being told specifically that I had to use the Pythagorean identity, I would not use the Pythagorean identity. I would have just drawn myself a triangle in the first quadrant, having an x value of 3, an r value of 4, did Pythagorean theorem to get my y side, and then just said that sine was y over r. But we wanted to follow directions. It's important to see that we can, get the same answer using different techniques. But please know, if you're just asked to do this without being told you have to do Pythagorean identity, way easier to do that triangle work over on the side. Next, we are going to write the first trigonometric function, cotangent of x, in terms of the second trigonometric function. Doing this is very helpful when we are verifying trig identities and solving trig equations. So we want to start with cotangent and end up with just sine. So what do we know about cotangent of x? Well, it's the reciprocal of tangent. That doesn't help us get a sine. Using our quotient identity, cotangent of x can be rewritten as cosine of x over sine of x. Good, we're halfway there, right? Denominator sine, but I need to turn that cosine into sine. This is one of the times where we use our Pythagorean identity. This is very common that we do this. So our Pythagorean identity says sine squared plus cosine squared equals 1. I'm going to solve this equation for cosine. So let's subtract sine squared from both sides. Gives us cosine squared equals 1 minus sine squared. And then I'm going to take the square root of both sides. And we get that cosine of x is equal to the square root of 1 minus sine squared x. Because we want it for algebraic purposes, we're not going to put the plus or minus there. We're just taking the principal root. So cotangent of x can be rewritten as the square root of 1 minus sine squared x all over sine. It can be tempting to want to simplify that sine squared under the square root, but we cannot do that because there is a plus or minus sign underneath the radical. It might also be tempting to simplify the two signs, but we certainly can't do that either because one's under a radical and one is not. In our next example, we want to rewrite the expression in terms of sine and cosine only. So let's start with secant of theta. We want to rewrite it just sine and cosine. So secant is going to be 1 over cosine. And then we have cotangent. Cotangent is cosine of theta over sine of theta. And then we have times sine of theta. I'm just going to put that over 1 so everybody's a fraction. And now we want to simplify as best we can. Oh, notice that cosines cancel out and sines cancel out. We're actually left with just 1. Let's do the same thing for the next example. Let's rewrite it in terms of sine and cosine only. There's 2 different ways that we could approach this problem. We could rewrite secant as 1 over cosine right away, but then we're going to have to multiply out, and I don't know. I'd prefer not to multiply out a fraction if I don't have to. So I would recommend multiplying this out first, just to get that out of the way, and then rewriting it in terms of sine and cosine. It'll just make our multiplication easier. All right, let's multiply this out. Secant times secant, secant squared theta, secant times 1 plus 1 secant, negative 1 times secant minus secant of theta, and then a negative 1 times a positive 1 minus 1. Well, our secants in the middle are going to cancel out, and we're left with secant squared theta minus 1. And then from here, we have 2 options kind of as well. So I like to show you both, so whichever one your brain feels more comfortable with, that's the route I want you to take. So the first thing we could do is we could just jump to rewriting secant in terms of cosine. Oh, secant squared is going to be 1 over cosine squared. And then we want to simplify by adding or subtracting these 2. So we'll have to get a common denominator of cosine squared. So this becomes minus cosine squared over cosine squared, which then gives us 1 minus cosine squared all over cosine squared. So that's one good option. But from here, we have another option on what we could do. Secant squared is part of a Pythagorean identity. Tangent squared plus 1 equals secant squared. So if I subtract 1 from both sides, I get that tangent squared is equal to secant squared minus 1. So when we see that secant squared minus 1, we could just replace it with tangent squared. So our other option would be from that point to go to tangent squared theta. Remember, we're ultimately trying to write in terms of sine or cosine. Tangent is sine over cosine, so this would become sine squared theta over cosine squared theta. So that could be another option for us. And these are equivalent expressions because we know from the Pythagorean identity, our first one, that sine squared theta is equal to 1 minus cosine squared.